In today's episode, I wire up the layout, motorise the points, and uncouple some locos. I've set out on a challenge to recreate Ffarquhar, the final station on Thomas the Tank's Branchline. While the Talyllyn Railway have restored Awdry's original layout, my model railway will take full advantage of all the latest innovations in the hobby. This is my most ambitious project to date, but what better way to celebrate the 80th anniversary of the Railway series? Hello everyone, welcome back to my channel, That Model Railway Guy, and welcome back to the series where I'm embarking on a journey to recreate the Reverend W. Awdry's model railway of Thomas's Branchline station, Ffarquhar. Now last time out I managed to build all three baseboards for the layout and lay the track, but so far I haven't been able to get trains running yet, so that is going to be the main priority for this week. Now that means I'm going to have to wire up the track power for the whole layout, but there is a bit more to the story here. You see, this is the first model railway I'm building as an exhibition layout. All my previous projects were built for personal use and then were later taken to exhibitions, but Ffarquhar I'm building from the ground up to be displayed. Now, one thing I have learned from doing exhibitions in the past is that, partly because of this channel, I don't get a lot of time to actually operate my own layouts at shows, mostly because people want to talk to you about the layout and, the channel as well, which is always lovely, and I'm more than happy to talk to people and encourage them within the hobby. Now, luckily my previous layouts all had at least one continuous circuit, so I could just leave a train running around the loop while I talked. But Ffarquhar is an end-to-end terminus layout, so that isn't going to be an option here. My solution then is to automate the whole layout using computer control to bring multiple trains in and out of the station and even shunting things in the yard to keep people entertained. Now, setting all this up is probably a whole series in itself, and that is something I am considering doing for the future. But as far as building the layout is concerned, I need to wire everything up for block detection, which is one of the many things I'll be tackling today. The sooner I start, the sooner I can get trains running on Ffarquhar though. So let's go, full steam ahead. Welcome to the underside of the three baseboards for Ffarquhar. As you can see, there's no wiring under here yet, just the unconnected feeder wires poking through from the track above. Like with the track laying, I'm going to start off with the head shunt board as it's the most simple of all three sections. With the module turned over to expose the underside, the first thing I'm going to do is add some extra bracing to the baseboard. I laser cut these pieces at the same time I made the baseboards, but didn't install them initially as I wasn't sure where all the point motors and track feeds would be positioned. You inevitably end up with the bracing being in the wrong position, and so I tend to fit them afterwards if I can. Now, as my version of Ffarquhar will be powered by DCC, the main set of wires I need to install is the bus. This is the main power line that runs the entire length of the layout, and all the power feeders branch off of this to take power to the rails. This wire passes through the cutouts I've made in the bracing, but it can also be held down using little adhesive wire clips. To connect the droppers, I use some wire strippers to expose the metal inside. The red feeder wire is then wrapped around the end of this, and I'll join the two together a bit more permanently using some solder. And tape is also used to insulate this as well. And gradually I work my way along the baseboard, connecting all the red feeder wires to the red bus wire. I used to use connectors for hooking up these wires, but I never found any that I was particularly happy with. Sometimes they would be a bit inconsistent as well, and so I found the surefire way to get a solid power connection is just to solder the two together. Now you'll notice I'm only doing the red wires here, and that's because the black wires will run via a current detector for my automation. That unit will be situated on the next board along though, so the wires will need to cross between the sections. As I'll have multiple wires crossing over, I'm going to use D-sub terminal blocks. Now these allow me to connect up to 25 wires, which I can then hook up to another D-sub block on the next board using a single ribbon cable. And with the D-sub connector in place, I can start hooking up the wires. The black feeders are extended by twisting the wires together and adding some solder. The extension is then clipped down so it can be run back to the D-sub block where it's screwed into one of the terminals. And the same is done for all of the black feeder wires on this section. Even on a simple board like this, we still have 4 different detected sections, so you can see how quickly the complexity is going to ramp up. For the moment though, that is all the wiring for this particular baseboard, and now it's just a case of repeating this process for the other 2 modules. Again, the starting point is to install the bus wire, followed by soldering all of the red feeders to the main red wire. As I work, I'm being careful to clip everything down in an attempt to keep things nice and neat. I'm sure, as always, it'll look like a rat's nest by the end of it, but I can at least make an attempt to keep things tidy. Another thing is that you don't have to have a separate connection to the main bus for each feeder. If you have lots of feeders close together, you can see here I've joined several of them to the bus wire at a single point, which does save a bit of time. Now it's time to tackle the black wires properly, but before I do, I think it's worth explaining why I'm doing these separately. Okay, so I think it's time to explain the concept of block detection and automation for model railways. It might all sound a bit complex and scary, but actually the basics are fairly simple. So, in order for a computer to run your model railway, the computer needs to know where every loco and every train is. And the standard way to do this is to separate the layout into lots of different sections, or blocks. We then need a way for the computer to know whether a train is in a block or not, and ideally, what specific loco or train it is. So for this we need a detector. Now, there's lots of different types of detectors available. Simple things like reed switches or light sensors that get tripped when a loco passes by, they can be used. But what I'll actually be using on Ffarquhar is a DCC current detector. Now, these monitor the electrical current in a section and can tell the difference between when it's empty and when there's a loco in the block. In fact, some of these current detectors are so sophisticated that they can even read the railcom data from a decoder and report that back to the computer. So it not only tells you that the block is occupied, but what specific loco is in that block and what speed and direction it's travelling in. Now, wiring this up is pretty simple, as we only need detection on one rail, and so that's why I connected up all the red feeder wires normally earlier on. For the second rail though, we do need to isolate all the blocks from each other. This can be done using plastic fish plates over baseboard joints, for example, or even using the isolating sleepers from Modeltech that I installed when laying the track. The black wire then runs from the bus to the detector box, and from here I have 8 different feeds that can then branch out to each section. The box is then connected to the computer, or you can daisy chain this to the next set of detectors before eventually connecting up to the computer. Now, here's a rough plan of Ffarquhar with each block shown in a different colour, but several of these blocks actually have multiple sections within them that are all isolated from each other, and this gives the computer more information on where something is in the overall block. Being honest, this is a really quick overview of how automation and block detection works. It's a massive topic and something I would like to do more videos on in the future, but it's also not for everyone. In my case, it'll be handy for running the layout at exhibitions, but for most people, a lot of the joy of having a model railway is being able to run your own trains. Like I said at the start of this build though, I want to make use of all the modern technology we now have available in the hobby. Things that Awdry would have had the option of using if he were building Ffarquhar today. So, with that basic introduction to block detection sorted, let's actually get it all wired up. This is the current detector I'll be using, which is part of the Roco Z21 range. That's the DCC system I use for controlling my trains, and while you don't have to use the same brand for your detectors, Personally, I like the fact that I know everything is compatible and talks to each other easily. With the unit screwed in place to the underside of the baseboard, I can get it wired up, and the first thing to connect is the DCC power bus. I connect some extra feeder wires to the bus, and this will not only send the DCC signal to the detectors and track, but it'll also power the unit as well. And once all the black wires are connected up, I can just plug them into the unit. I have 8 outputs on this unit, and this is what all my black feeder wires are screwed into. Now currently I've only got 4 running from this particular detector unit, but don't forget I still have the feeders from my other baseboard as well. So I need to install another D-sub block to receive those wires from the first module. I'll then run 4 feeders to this, mirroring the black wires that I ran to the D-sub on the first board. These run back to the current detector, and that way I can use all 8 inputs to detect different sections across the 2 different baseboards. When it comes to electrically connecting the boards, the first thing to do is to join the DCC power bus. I just use some push-fit connectors on the end, which are standard across all of my layouts. With the main power taken care of, the ribbon cable between the 2 D-sub connectors is plugged in as well, and that will take care of everything else. I will eventually use this for other things like lighting, even the points network and servo extensions, but we'll get to all that later on. So with the layout wired up, it's time to see if I'm actually getting power to the track. Now, a really simple way of doing this is to plonk a loco on the track and hope for the best. But with an expensive model, you might not want to take that risk. Or if you've got a large layout, testing every little bit of track could take quite a while. So Model Tech have come to save me once again with their power indicators. These have a contact pad on either side and an LED in the middle, which when you put it on the track, the LED lights up if you're getting power. This works for both analog and digital. On DCC, I get an orange light, and on normal DC power, you get a red or a green light depending on the polarity. This is a really easy way to check every part of your layout is getting power, as it's so quick to move it around. Thanks to the LED, it creates a little bit of resistance too, which means it triggers the current detectors as well. As I move the power indicator around the layout, you can see the different outputs lighting up on the unit. Crucially though, only one is lighting up at a time, and that means I've got everything wired up correctly. Again, if I was doing this with a loco, it would just take a bit more time, but it's so quick just moving the power indicator back and forth to make sure that everything is responding correctly. So another great product from Model Tech here. Like I said in the previous episode, when I was laying the track, their rail aligners are really useful too, and it's made building this layout a lot easier than it would have been without them. If you're interested in checking Model Tech out, I put links down in the description to everything I've used, so go have a look at their website and see what they have to offer. The power indicators though are a brilliant little bit of kit. I can see them being super handy for fault finding at exhibitions or even when you're getting your layout first set up. For example, because of the current detectors, all of the different parts of my layout are isolated from each other, but I had completely forgotten to run any feeders to the points. Now thankfully this was only the case for the black wired side, so I could just add an extra feed from the main bus to these. With a small hole drilled between 2 of the sleepers, I'll add a little bit of solder to the side of the rail. We're actually looking at the layout from the rear in this instance, so while it may look a little intrusive initially, you won't actually be able to see this when viewed from the front. A new wire is then soldered to the rail, and that's fed through the hole I just drilled. And with all the excess wire pulled through, you can see it's actually already fairly discreet. Underneath, this wire is then connected to the main power bus. Now I could run this to a current detector, but to be honest I don't have enough outputs and the detectors aren't exactly cheap. The software I'm using also doesn't need detection on the points either. As long as you've got a detector either side of it, it's able to account for that small undetected section as it passes over the point. This same process is then repeated for the other points on the layout as well. When there are 2 points joined together, I only need to add one extra feeder as the points aren't isolated from each other. That's another benefit of using the Unifrog points from Pico, and it saves me a bit of time. Putting the power indicator back into use again, you can see this time the LED shows that we now have power to the points. As this appears to be the case across the entire layout, I think it's about time I got a loco running, and to do the honours, I've chosen the Bachmann 812 class. Not only is this a fantastic runner, but as I'm sure many of you will be aware, it was also the basis for Donald and Douglas in the Railway series, so it very much feels appropriate for this layout. And the first success though is that it moves, so this is the very first loco to ever run on Ffarquhar. There's no issues over the baseboard joints either. They might need a little fettling just to eliminate that slight bump, but it didn't derail, which is fantastic. And we can run the full length of the station into the head shunt. I'll just switch the points manually by hand, and then we can run into one of the sidings. Again, the running is nice and smooth, and I have to say, it's great to be able to see a loco moving under its own power. There are several key points during a layout build that always stand out, and running the first loco is definitely one of them. And even though the modules of this layout aren't huge individually, I do actually have a decent length run, especially for the sidings. Now this is a major step forward, and for a lot of layouts this is where you could start to work on the scenics. But I have bigger plans for Ffarquhar. With the track electrics now operational, my next job is to motorise all the points. You may remember I drilled holes for the motors before laying each point, and so now it's just a case of attaching a motor and wiring it up. I like using servo motors personally, complete here with my own laser cut bracket and piano wire for the arm. The wire is fed through the hole as I manoeuvre the motor into position. And you can see the wire comes out through the point, interfacing with the switch mechanism. With the servo motor in place, I can now just screw this down. I suppose I could always glue the brackets in place using PVA, but if I ever have an issue, undoing the screws to service or replace a motor is going to be a lot easier. The whole process is then repeated for the other points on the layout. The laser cut brackets actually make this a really easy job, especially as there's only 6 points in total on the entire layout. To control the motors, I'll be using a Megapoint servo board. I used these on my modular layout, and as I'll be reusing the fiddle yard for Ffarquhar, I want everything to operate the same way. They won't actually be connected electrically, but I've standardised on this system now, which keeps the whole layout consistent. With the board installed, I can then plug a couple of servo motors in. Because I'm using Unifrog points though, I do want to be able to switch the polarity of the frog. Now on my TT120 layout I use solenoid motors that came with a built-in switch, but servos don't have that. Luckily, Megapoints have a relay board which I can use in tandem with the motors. With the relay board installed, a single wiring loom is plugged in to join it to the servo controller. And as I'll be using them to swap the frog polarity, I need to have the red and black DCC wires connected either side. These can also be daisy chained along to keep the wiring simple. get power to the frog though, I'll have to solder an extension to the wire that passes through the baseboard. This then goes to the centre terminal for one of the relays, matching up with the corresponding point motor. With the servo board then powered on, I can program the motors using the high and low buttons to set how much they move. Once I'm happy that it's switching the point in both directions, I can give it a quick test. And as the servo moves, the relay also fires as well, demonstrated here by the light going out. And when the motor comes back the other way, the light comes back on and the relay switches the polarity on the frog. With the baseboard the right way up again, I now need to trim down the piano wire coming through the points. Now I tend to do this using the Dremel, but the key here is to go slow. Cutting this wire creates a lot of heat and that gets transferred through to the plastic mechanism. If you're not too careful, it can melt, messing up all your hard work and potentially damaging your point too. So that's why I'm doing this in short bursts, allowing the heat to dissipate before I carry on. With the majority of the wire then removed, I grind down the rest, trying to get as close to the point as I dare. Again, the heat buildup has to be taken into account here, so plenty of patience is definitely needed for this task. With the wire eventually removed, I can now test out the points properly. And as you can see, the blades are switching back and forth really nicely. This is another big step forward, as motorised points are pretty much standard for most exhibition layouts. Of course, having the points motorised is great, but there would be nothing to actually motorise if we didn't have any track. And that's where D-Rail's model shop have really come in handy. They supplied all the track for this layout, and the reason I bought it from them is because at the time they were running a special multi-buy deal on points, where the more you buy, the bigger a discount you get. Now, that offer ended a while ago, but when D-Rails came on board to sponsor this series, I'm excited to say they've agreed to run the deal again, just for you guys. So, if you want to try out the bullhead track for yourself, the 369 deal is available once again just by using the link down in the description. That gives you a 3% discount on 3 to 5 points, a 6% discount on 6 to 8 bullhead points, and then a little bonus of 10% on orders of 9 or more bullhead points. And this is perfect if you're in the process of building a layout and are doing a lot of track laying. The points are often one of the most expensive parts of a layout, and so getting a little bit of a discount on them, especially if you need a few of them, is really handy. Now, this offer was really popular from D-Rails when I promoted it last year, so if you're thinking about it, make sure you get over to drails.co.uk sooner rather than later. And again, a big thank you to D-Rails for running this again, and also for just making this whole series possible. Back to the layout though, Awdry actually had remote operation of the points on his version of Ffarquhar too, so while my way of doing it is a bit more high-tech, the basic concept is exactly the same. Something else that Awdry had on his layout was the ability to automatically uncouple locos and rolling stock, and I really want to be able to do this too. In fact, with an end-to-end layout, it's pretty crucial, especially for running around passenger trains, and Awdry used the Sprat and Winkle couplings on his layout. Personally, I tend to stick with the standard tension lock couplings, and I know many people out there will scoff at this, but honestly, the look of them just doesn't bother me. When it comes to uncoupling though, the simple option would be to use something like a standard ramp from Hornby or Pico, but I want something a little less intrusive. One of the first videos I ever posted on this channel was about invisible uncouplers, demonstrating how a clear piece of acetate can be placed between the sleepers to create a near invisible ramp. I then took that idea and updated it using servo motors on the TT layout last year, and it's worked really well, so I'm going to do the same for Ffarquhar, with some slight upgrades. This time I'll be using brass rod to support the uncoupler, so this is placed in a vise and cut down to length using the Dremel. With the rod cut, a piece of wire is fixed to one end in what must be admittedly some of the very worst soldering I have ever done. So here's a general assembly of the mechanism I have in mind. A spring from a biro pen goes onto the rod, followed by a 3D printed shaft which will pass through the baseboard. I then have a cap to go along the top, which will hopefully blend in with the ballast and have the acetate strip glued on top of. The idea being that the servo can push the brass rod up and the spring will help it return to zero when retracted. I'll have several of these across the layout, so I'm making these mechanisms up as a batch. Now to install this on the layout, first I'll need to actually drill a hole between two of the sleepers at the location where I want to be able to separate locos and rolling stock. The guide shaft is then glued in place, and this will just stop the rod from moving side to side. You can see it sits level with the baseboard surface, so once the ballast is down it won't be seen. Once the glue is dry, the rod can then be pushed through and the cap can be added on top. Underneath the baseboard, a servo is mounted in position with the wire from the rod passing through the servo arm. And in the end I opted to do away with the springs as I found they weren't really needed. Happy with the position of the motor, I can then fix it in place using a couple of screws. The wire from the servo is then plugged into the control board, just like the points before. The only difference this time is that the motor will be creating an up and down motion instead of moving side to side. For now I'm just using some black tack to hold the acetate, but eventually these will be glued in place. So, doing a quick test with a wagon placed over the top, the servo moves the acetate upwards and that lifts the hook on my tension lock coupling, and this is exactly the result I was hoping for. Great, so I know it works in isolation, but does it work as well in a practical setting? Well, I guess the only thing to do is play trains. I mean, do some testing. So, arriving into the future site of Ffarquhar station is everyone's favourite little tram engine.
Toby arrives up from the harbour at 2:21.
Having arrived at the station, normally Toby would need to disconnect from Henrietta and the quarryman's coach so that he can run round to the other end of the train for a return journey. So let's try that out. The servo lifts up the arm, and Toby is able to pull away smoothly, leaving his coaches behind. Now this is another major success, as being able to disconnect and run round coaches without manual intervention is a really crucial feature for this type of layout design. I haven't just added this one uncoupler though, I've added some more in the sidings too, so let's try out a little bit of shunting. I'm thinking that between passenger trains, Toby and Percy can shuffle some wagons around to keep everyone entertained.
Toby has some shunting to do. He sets back into the siding and proceeds to collect the wagons which Percy had left there in the morning and which now have been unloaded.
In this instance, I'm using some SECR wagons, so you'll have to forgive the inconsistency of running these with a Great Eastern locomotive. Pulling the wagons forward though, there's another uncoupler hidden in the track, and this will allow me to seamlessly disconnect the front two wagons from the rest of the train. Toby can then move these two wagons over to the other siding. There's also a reason I'm using Toby for this test as well. The Rapido J70 is a fantastic model and is certainly nice and controllable at the slow speeds. But it does have a very rigid chassis in my experience, so it'll find every little bump in your track work. Now this is giving me good information on little things I can adjust and fettle to get smooth running, and if this loco runs well, then pretty much everything else will be fine. Once again, I've made a lot of progress today, getting all the track detection wired up, motorising the points and installing the uncouplers. Of course, there's lots more to come with this epic project, so make sure you subscribe to see the next episode where I'll finally be starting work on the Scenics. And if you just can't wait, you can become a channel member to watch that episode right now, and here's a little teaser of what's coming. I try a new track weathering technique, the platforms are constructed, and ballasting commences.